Uh, Good morning, everybody. My name is Bharat, and this is PiLot, a platform for indoor location-based applications. The people who are going to be presenting with me is Professor Carol Davids, Dee Wu, Neil, and Tracy Francis, but he couldn't be here this morning. He feels very sad about it. For PiLot, we had a development team consisting of Alberto, who's in the audience right now, myself, Dee, and Neil. We also have our project mentors / awesome human beings, Carol Davids, the invaluable Carol Davids, the amazing Carrie Davids, who helped us with all of our hardware, and then Bruce Nardi from Argonne Lab, who designed our prototype for our devices and also provided invaluable advice for this project. I also want to give special thanks, of course, to again Professor Carol Davids and Joe Cusimano, who is an amazing asset and who helped us with the NG911 side of this project. We also want to give a special thanks to Eric Hagerson from T-Mobile, who funded and brought this idea to us in the first place. And another special thanks to Oracle, who donated their SBC. And another special thanks to Brian and Chris, who helped us configure the system for us. The IIT Real-Time Communications Lab is an educational facility where industry experts and the students can meet. It's a lab where we conduct a lot of research projects and everything else, and all in all, it's an amazing place to work at or to just sleep if you've been working on projects for like 3 or 4 days straight and something just won't work. I won't get into more about that. Anyway, the history for this platform was based on a Wi-Fi system that was designed, and we presented about it last year here at the conference. The Wi-Fi system was based on the internal infrastructure here at IIT, and we developed a location service using our internal Wi-Fi infrastructure. But with this system, we also had a ton of drawbacks. One of them being that the implementation that we made was very specific to our vendor here at IIT, and I couldn't, and the phones were not able to locate themselves, but rather the phones would provide their MAC address to the infrastructure systems, and then the system would then locate the phones for us, and the phones were not independent, or they were not independent of the system at all. And while we did get a good amount of accuracy, and it was better than what the FCC asked us to do, the solution did struggle a lot of times by getting the wrong floor because of the bleed-through effect that our Wi-Fi devices have. So we decided to pivot in a different location, into a different system, and that is why we had a set of requirements. One of them was it had to be independent of the infrastructures. It needs to be compatible with phones that are at least 3 years or younger, and it needs to be able to provide negligible bleed through to floors. We know that sometimes signals do bleed through to floors, but we needed to figure out a way to make sure it's negligible enough that it won't hurt our location services. We also wanted to make sure that this solution could be easily retrofitted into older buildings, which I mean, if we wanted to make our Empire State Building completely Wi-Fi, I wonder which vendor would like to take that on. So, and then finally, we wanted to make sure it was a clear solution, fast to deploy, and easy to monitor. So that's why we decided to go with PiLot. And why we decided to move away from Wi-Fi and move to Bluetooth Low Energy. Now, while Bluetooth is available in almost every phone, please raise your hand if you have a phone that doesn't have Bluetooth in it. Okay. If you did raise your hand, I would have offered to buy you a new phone. Just saying.
Seize the moment.
Bluetooth IB. The iBeacons are very cheap. And easy to deploy. They consume very little power, so their energy footprint is very little. And the iBeacons are independent of each other. They don't rely on a system. They're just guys. They're just lighthouses sitting at locations, helping the phones find themselves. So our concept was a management system for iBeacon devices, a location-based algorithms that we have developed, an open API for device independence, ready to deploy devices, and remote software updates and control. And we provide simple install, being able to retrofit older buildings, regardless of what kind of IT infrastructure that you might have in that building. This solution is available anywhere where there is an internet connection available, and it provides us indoor location. The two modules for our system are the PiLot core devices and the PiLot management system. And the PiLot core devices are the iBeacons that we place everywhere, and the management system is how we administer all of our devices. The PiLot device core has two parts to it: the Bluetooth module, the HM10, which is our Bluetooth iBeacon, and the particle photon, which is a Wi-Fi Arduino board, which allows us to administer these devices. These boards have Wi-Fi, so we can connect those to the internet. We can monitor these, and if we need to update the firmware or reconfigure our Bluetooth devices for any reason, we can easily and remotely flash them, so we don't need to go back to each and every Bluetooth device, pull them down, reconfigure, and put them back up. The Photon does that for us. So for this thing, we have deployed about 20 of these devices in IIT Stewart building. It's
Per
building
floor.
per floor. I was going to say that, but it has a density of 20 devices per floor, and they provide an accuracy of up to 5 meters. But the solution had a few drawbacks, and those are the management hardware that is the Photon device consumes a lot of battery. So our biggest issue with our devices currently is the Wi-Fi boards just consume a lot of battery. There are some internal bugs in the firmware of the devices that may cause these devices to just go into an infinite loop that sometimes just breaks it and drains the battery out. A lot of components in the core also increases the likelihood of systems failing, and it's very expensive to put a Wi-Fi Arduino board on each and every Bluetooth chip, and it's not very scalable. So we decided to pivot again to a different direction, and this is where we got the PiLot multi-point core, where we have an Intel Edison, which is a nice little general purpose computer, who will be the essential master, scanning its area, making sure all the beacons are available, and just a HM10 Bluetooth module, which will be the slave, which we can have multiple of. It's going to be a star network where the masters basically are placed at a single location. They are connected to the internet 24/7, and they monitor the network. Network and make sure that all the beacons that are within its range are reporting. And if any beacons went down during that time, we get an immediate notification, so we know if a beacon's gone down or something like that. This system is much more easier to scale. We can and again it works great on Wi-Fi or Bluetooth. Neil will speak to you. No, Dee will speak to you about the. Me? Neil
You
will speak to you
introduce.
about the location server, and Dee will speak to you about our database services.
That's a good idea.
Sure.
That would be a good idea, I think. yeah.
Does anyone have any questions? No.
Okay, so the location server and database, all our Bluetooth, or once the phone, or when you actually want to get your location, then you need to talk to somebody to get to that location, and so that's the location server and database. I'll talk about the server first, and then Dee will describe the database. So the location server is just a web server that receives a list of all the Bluetooth packets that the requesting unit had scanned for. So when it wants to find out its location, it scans the environment for all the Bluetooth, for any Bluetooth talking, collects all the packets, sends it to our web server, which is the location server. These packets include the core ID, major, minor, and RSSI, the signal strength. Core ID, major, and minor are just the identifiers for the Bluetooth device that was signaling. And then the server just takes these takes this list of Bluetooth packets as input, runs an algorithm to select which Bluetooth device is actually closest to the requesting unit, and then it responds. It responds to the requesting unit with the human readable location of that Bluetooth device, which it pulled out of the location database. And then we are currently developing algorithms to, instead of trying to find the closest Bluetooth device to your location, we'll try to find your location. But that kind of that would be through triangular or trilateralization, which is currently not implemented. Dee will talk about the database.
Yeah.
Not all have attended that session.
Somebody was supposed to put it in.
Yeah, we missed that one. Sorry. And for the database, we have three main parts of the database: the administration, the experiment, and the geographic information system. For the administration part, this is being used for administrators for daily updates of all the Bluetooth devices. And for the experiment, we put it here is just to show you our progress of the project, because this is just proof of concept. In the future, we're not going to use the tables under the experiment, but this is being used for us to do the research. And for the geographic information system, we're going to use those tables for future applications. Those are the administration tables. On your left-hand side, we have event log table and device status table. Those are daily updated information for our Bluetooth devices information. And the deploy location table is used for the devices which are deployed in the location. And the location use table is used to map our deploy location and devices information table to our experiment table. For every 1 or 2 months, we will have an experiment when we have new algorithms or we have different infrastructure of the Bluetooth devices. And under each experiment, we will have several test runs. We might run the experiment in the morning, during the noon, or at night. This is just used for us to analyze maybe the crowd, to influence the devices or the algorithms. For emergency scenarios, we might have the influences because of people crowd. That's why we have different test runs. And under each test runs, we will have test events. Once we click the button to make a phone call, we call it one test event. And under the test event, we will have 10 scanning time. And the test data table will collect all the data within that 10 seconds scanning time into the test data table. And we have 3 tables under the GIS. I mentioned deploy location table and test location table. The reason why I mentioned those 2 tables here is we have the XY coordinates that will be used in the algorithms to analyze people's real location. And we have the floor map table. We have the northeast, northwest, and southeast, southwest coordinates. This is being used for us to in the application for the polygons. We have several different usage based on our database. For researchers, we can use the data to analyze the accuracy of algorithms. We can analyze the infrastructure of Bluetooth devices so that we can get the most accuracy distance between between each Bluetooth devices. We can also analyze influences between each devices and also analyze the success rate of experiment. For administrator, later Neil will show us a demo that administrator will use this UI to check the battery status, the location of devices, and check the versions. In the future, we're hoping that we can use this database for emergency call dispatcher UI and for fire evacuation and also for visually impaired people. And then Neil will show us the demo of the administration page.
Just click it. Yes. Okay, so just FYI, in your mind's eye, you should rewrite anything you see here as a beautiful rendition that does not exist currently. What? Including that.
Press escape.
Are we not on the internet?
We
Are
should
we
be.
not on the internet?
We should be. Link, click on the link.
Go.
Control
There
keyboard.
it is.
Oh, there you go.
All right. So this is what Tracy has been working on. This is the administration page. So the admin dev, and then yeah. So I don't know what that is.
This
I don't know what that is.
what you're looking at now is a work in progress. We have a database, but it was not that user-friendly. We could look at an enormous table. So what the students are what we're working with students who are taking Java classes, and they're building us a front end, a more user-friendly front end. The students observed that there were several different types of user of this system. There were experimenters, there were administrators, and then there were actually first responders. So they wanted to have a different view depending upon who you were. So he's showing you the if you're an administrator or an experimenter, you have to know whether your devices are actually up, whether their batteries are running low, and so forth.
Right. So the idea is that, at least for this view, you'd have a map of the entire series of buildings that you own. In our case, it's the entire university, so it's a big map. But Stewart's the only one we have deployed in. But you click Stewart building to see all the devices in the Stewart building. Then you hit your basement ground. We've got 3 floors in it, so you select one, and then these little things are meant to be the Bluetooth. Can you see it?
Just they're not. He
Okay,
took
well-
them at random. They're
No,
not.
I mean, you can't see the floor map. It's
No, but
way too
that's a placeholder. Why don't you show them your voltages?
All right.
Because these are what we as administrators and experimenters we have to maintain them. So we watch the voltages as they pirouette.
Yeah, and they like to do some crazy things. In this case, it's just shooting up because it got charged. But otherwise, it's got a nice steady die rate. They'll die slowly, and it takes about 6 months for them to die currently. And we expect to go longer once we remove Wi-Fi from each Bluetooth device. And if they're just Bluetooth, they'll probably last for a year or more.
So what?
When you say die, the battery power goes away, right? I mean, 6 months Is the
Yeah, so
lifetime?
currently the devices with the Wi-Fi module, they wake up once a day and report to us. And each device has its own little Wi-Fi module to do that independently. So currently they last for about 6 months, if you extrapolate the slope. But once we switch to the master slave and we remove the Wi-Fi chip from each individual Bluetooth device, we should expect them to last for more than a year or so, while sitting in the wall.
Yeah, what happened, yeah, are you more to demo? Yeah. We've found, and this was, I'd like at this point for the panel to speak as a panel and to take your questions, and I want to bring up to you some of the very interesting things that the team has done this semester and over the summer, as we realized that more and more of the work that more and more of the code that the students were writing and more of the design issues that they faced had to do with the administration and operation of this set of devices. And so there's been a wonderful flow back and forth, changing design as we realized what would and wouldn't work. Initially, for example, they have the Wi-Fi embedded in this Arduino board, which is there only to administer. We really only use the Bluetooth. So the Bluetooth uses very little energy. However, the Wi-Fi and the Arduino board use a lot of energy. So in the course of the code writing this semester, they had to basically write code for the Arduino, so it would only wake up once a day, take the temperature of the battery, report it to headquarters, and then go back to sleep. And they solved many coding problems, and while they did that, as we watched the batteries drain very fast when we didn't anticipate they would, and we debugged our code based on watching the curves of the demise of the batteries. But we found we wrote a lot more code for the administration and maintenance of these devices than we were ever writing for the actual application. So we originally started this platform, and here's another point I think for discussion. So the platform we developed specifically for one application, and that application was the indoor location to provide to an NG911 PSAP and to dispatch and to the first responder. So that was the original reason that the platform was developed. As we developed it, we realized it had an existence beyond that single purpose. So, in fact, the students came up with the concept that this was a platform, and it could be separated from that one application. So our goal would be now to have other application developers develop different applications that would use the same platform. The platform consisting of the two parts, basically, the array of Bluetooth devices and the database and the location, the indoor location server that uses that database. But many, many interesting design problems had to be solved, including how to integrate all this information into one huge database, which we would then derive tables from, depending on whether you're a first responder, whether you're an experimenter, or whether you're whether you're the administrator. We have to have the devices up all the time, otherwise the location database is inaccurate and we may be sending you to the first responder to the wrong place. So I don't know if people have questions. I'm going to subside, but I think that there's many interesting questions. I think Dean and then...
A couple of questions. Any idea on what percentage of phones have Bluetooth switched on at any point in time? I suppose the other question is, what's a reasonable expectation for the number of buildings that might have these beacons in? Because I suspect that it's going to be hard to persuade residential users, for example, in future to use them.
Well, well, for the percentage of phones that have Bluetooth beacons turned off, I envision it to be when this goes mainstream and when this is in everybody's phone, when they dial a 911 call, the phone automatically kicks Bluetooth on. So that way, if we have a situation where someone's turned off their Bluetooth and they're in an emergency, they dial 911, the phone turns Bluetooth on, and then just starts doing its scan. That being said, for residential buildings, we spoke with some people from the FCC, David Simpson, right?
Mm-hmm.
Yes, and he said that if we can somehow figure out a way to get this into the fire marshal's code, then that works out for us. So putting it in law, saying, hey, it's part of the fire code, then we have it in our buildings now.
But to that point, Alberto, who wrote the code for the NG 911 application, in our code, the first thing after the triggering event of me dialing 911 or the emergency button, it immediately makes sure that Bluetooth is turned on. So it's in our code at the moment. And when we did the Wi-Fi, the first thing we did when the person dialed the 911, the application code for the phone, so it's the app for the phone, just turns on Wi-Fi and Bluetooth. In the case with the Bluetooth, it just turns on Bluetooth. So we took care of that possibility. Yeah.
Yes.
I wonder in the development of this system, you're depending upon the Bluetooth beacon signal strength.
Mm-hmm.
And the signal strength can probably vary with battery voltage, with whether the unit is behind a post or various installation artifacts. And I'm wondering whether, once you got everything all set up, whether there was a student that walked through the whole building, went into each room, had a Bluetooth or had an iPhone movie running and something that would give a time track, and they would say, I'm in room A14, and then walk down the hall. And then after they're through with that tour, the data from all of the Bluetooth units would be correlated with those with that trip. And then maybe a month later, when things have changed a little bit, that same student tour would take place, and you could compare the readings at that time with the previous readings and get a lot of information on exact locations of these of the reporting device rather than just the Bluetooth units.
Yeah, they actually did that. And Nathania, who's one of the student leads here, was among the students, and I think Neil also, going around just to verify. One of the things we have to do is to verify that all of them are actually playing their role, that they're all beaconing. And we didn't have a remote way to do that immediately. So, but another team within our university has done a lot of RF testing, and so we plan to do a kind of a map, an RF map, because with the Bluetooth, there could be interference, as Dee already mentioned. There's interference even from bodies. Bluetooth low energy will be affected not only by walls but also by bodies. So in the nighttime, you might have different readings than in the day. So, we see this project as going on for several years, and one could see if there was a interplay between the variations in the RF powers and the accuracy of the location. So, yeah, but they did. I mean, Nathenia, I think, just walked in, but you had to go through, that's right. Nathenia was one of the lead students on that, and they walked through the building, taking exactly that type of measurements. Right.
Ready for another?
Yeah.
Okay. One comment first. Those of us that wear Fitbits, sometimes they get lost. And there are applications out there that, as you wander around trying to find it, it measures the strength of the Bluetooth signal, and it tells you when you're getting closer and closer. So measuring the strength of the signal is really a good way to proceed, you know, to try to figure out which one is the closest to you. But I was just at a conference last week, as a matter of fact, and this indoor location is a very hot topic right now. So this is really good that you're working on this. But as you may be aware, and I missed the first part of this, so I'm not exactly sure, but I'm taking it that these are Wi-Fi hotspots, the little blue dots, or are they just Bluetooth?
They're meant to be the Bluetooth.
Bluetooth,
but,
okay.
like, they're often recorded.
The FCC has mandated that the telephone companies report indoor location within X number of...
That was why we did this project, so it was,
Right.
yeah.
And the telephone companies have come up with a way to do it. And it's a proposal right now, but this is what they're proposing, which is very, very similar to what you're doing, except instead of Bluetooth devices, they're using access points. And they're measuring the single strength of each access point in a building, which are obviously always on, and that's how the phone calls get out, so they can measure that, and then they triangulate to figure out which one is the closest. Now, the thing that's, I guess, a little bit different is that the telephone companies, on a volunteer basis, you can, this is what they're proposing, is you will let the telephone company know the room number, the address, the location of each one of these access devices. They'll store it in a national database or databases, and that's how they're proposing to come up with the location of a call inside of a building. This may, in fact, be better because it's not volunteer. You actually know where these things are. But what you described as an app that turns the Bluetooth on every time you dial 911 may be the best way to proceed.
Well, we
actually did, that was the predecessor system. We actually did do it with the Wi-Fi access points.
First.
Now the problems with that is one of the problems is the phone cannot identify access point A with access point B, and that maybe that's just isolated to the solution that or the vendor that's put into our school here, but somehow they figured out a way to mask their MAC addresses, which is the only identifying information we get from a an enterprise Wi-Fi system like the one that's installed here at IIT. So because we were not able to identify each and every access point, we aren't able to say, okay, this particular access point is in this particular room in this building at this address. Now the infrastructure, the Wi-Fi infrastructure that IIT has they have designated names for each and every access point, and these access points then scan the environment and they get our Wi-Fi MAC addresses from our phones, and then they say, okay, the way the solution worked was we would send our MAC address to the internal infrastructure, and our phone's MAC address would then be scanned through the logs, and then we'd get a list of all the access points that have seen our Wi-Fi device, and then we would use an algorithm to calculate the location of that, and that is how it was previously done. But it's, again, very dependent on, the very particular solution that we have here, as opposed to maybe Cisco routers, which probably have, unique MAC addresses for each one of their access points, and then that solution would be completely different from what we did here at IIT. So we wanted to make sure it's a universal solution. We wanted to make sure the problem is solved universally, and we didn't need to come up with like 200 different solutions for 200 different problems, and we just wanted to solve the one problem, and that is trying to figure out where you are inside a building so that if you have an emergency, we're able to find you and save your life.
The logic that we use in the phone application now is applicable to a access point solution, but it wasn't on this campus because we use the Miru system, which unlike, I think, certainly Cisco and Aruba, I think, which I don't think mask the MAC addresses of their access points, Miru did. So we had a solution, as he pointed out, and we were within the FCC requirement of 10 seconds, from start to finish of the call. But it was ugly because what happens in the phone application is when the triggering event, I've dialed 911 or I've pushed the emergency button, when that occurs, it turns on the Wi-Fi, which then scans. And so he's putting out a probe request. The probe request is logged in the Miru administrative logging as an event. And then the students very cleverly wrote a parser for that event log. And they found the MAC address of the phone in that log and return the identification and the location. So it was backward from what the current application does. And Alberto might want to talk to you more about that. But we know now the phone just scans, looks for Bluetooth, and sends a set of visible Bluetooth to the location database. So it's turned on its head.
It might be possible to combine the two approaches and have each Wi-Fi AP include a Bluetooth element. So you would get the signal strength and the Bluetooth ID to help you identify where the phone was, and it might be. The other consideration is that the Bluetooth and Wi-Fi transmit over the same RF band, and if the two units are combined, Bluetooth and Wi-Fi, it's possible then to have the units separate by some time when the Bluetooth transmits and then when the Wi-Fi is transmitting.
So combining Bluetooth and Wi-Fi, that would be the long-term goal. We, of course, can't actually test it on this campus currently because they're masking the MAC address, but we kind of can. But
Yeah, we can. In fact, we had multiple goals for the project this semester, and one of them was to do a first cut at using both pieces of information simultaneously. We cover the whole campus today with the Wi-Fi solution, so and that works. I think at least 83% of the time we have accuracy that we consider we have success. We have 100% accuracy with the Bluetooth, but we control the coverage of the Bluetooth. We don't control either the coverage of the Wi-Fi, nor do we actually, we have it's not as well, we're not as accurate with the Wi-Fi right now. But what we thought is we have both of these. We can produce a location with both. And so we were going to try to do a first cut at merging those two pieces of information. I think the team had discussed in the long run, what we're looking for is an optimal solution where a business, a building owner, doesn't have to put in entirely Bluetooth infrastructure. If they have existing Wi-Fi, they might strategically put a small number of Bluetooth and sweeten the solution sufficiently that they have 100% accuracy or 100% success rate. So you've already got your Wi-Fi put in like maybe 5 Bluetooth per floor or something like that, and you would get a good accuracy. It's the same idea as if you want 5 nines, you get another vendor, right? So if you want 100%, if you want 100% success, and right now you're getting 85% with your Wi-Fi stuff, so you'll put in a few Bluetooth on a floor and you'll get your 100% and people's lives will be saved. So, but yeah, that was one of the things. But the other that the students seem shy to talk about, but I want to bring it up and maybe they'll talk to it after we start. Neil alluded to it, that right now we can tell you the location of the nearest Bluetooth device, but the next generation of our of the algorithms, we're going to identify the XY coordinate on each floor of the caller. Okay, and that, in order to do that, we're going to use trilateration, which is what he alluded to, but just to expand on that. So right now we tell you the closest Bluetooth, or the closest Wi-Fi access point, and we know where they are because those are pinpointed and we know their XY coordinates. So now using trilaterization, we know the received signal strength, and that's how they use that RSSI to tell you the distance. And I have these locate and all these other Bluetooth applications that do tell you the distance. So we'll use a similar process and see if we can actually give an accurate description of where the caller is, as opposed to where the Bluetooth or Wi-Fi is.
On the question of coverage, have you considered, or what are the challenges you faced in placement of the Bluetooth BLE beacons? So in order to get maximum coverage, or what are the challenges you are still continuing to face?
The biggest challenge was getting the ladders so we can put them into the ceiling. But for the most part, at least with the IIT Stewart building, they had false walls on the first floor, and then on the second floor they had doors with like black like windows on top. And so we were able to, at least for IIT's satisfaction, on the first floor we could just stick them in the inside of the ceiling, or the false ceiling. On the second floor we were able to just put them on above the door, where because our boxes are black and it's a black background, you don't really notice them. And, like, their main worry was theft, but otherwise we haven't seen too much trouble in actual placement of devices.
Keep these high, people wouldn't mess around with them, but they are very concerned that people will think that we're spying on them. So they've said they want to interview us for a publication, an internal publication, so we'll explain. These things are dumb. These things are just like radio broadcasts. They're not learning anything from you. They're standing there like lighthouses. They're just putting out my name is. They're not doing any communication. But that was the big concern, was that people would think we were spying. And we tried to become a part of a program in Chicago called the Array of Things, which that's what we are. I mean, we are an array of iBeacons, And we were told that they didn't want to put up any Bluetooth because the people of the city would think they were being spied on. So.
The building that we placed in does not have too much heavy machinery equipment. I believe they're mostly computers, right?
Yeah.
Yeah, so the computer science department's in that building, so we don't have any like high-end machinery or anything like that. So it kind of was like the nice ideal RF place where we won't have any dead drop zones except for places where people have their microwaves, I guess. But most of our placements, we also made sure were in public areas, and we didn't place any Bluetooth. We didn't place any devices where we would not have 100% access to them too. So we didn't place them inside anybody's offices or anything like that. So yeah, just to be
But
safe.
that's a good question, I think. In the same way, even we used to run around in trucks, and when I was at Motorola, you would measuring the RF spectrum in the neighborhoods, right? We thought we'd have to, and that's to what you were saying, you just go through and use that map. If we get sophisticated enough in a building, then you would use that information to modulate the information that you're getting from the RSSI.
Since Bluetooth only goes about 30 feet, how many devices or sensors did you have to put in that building? And if you want to do the entire campus, how many sensors are you planning to use?
For the Stewart Building's size, we plan to go with 20 devices per floor, but even that we feel is a little too dense, and we are planning to reduce that count, right?
We already tried that.
Yeah.
Yeah, you have to say, Brad graduated and he's been working for several months away from the project, so
So recently we had 20 devices per floor, and then we dropped that to half, where we just, every other device, we just turned it off. And we ended going, if I remember correctly, it was 17 meter radius, like, okay. From the last presentation, or from yesterday's, you have a tester, if you have a given tester location, then a valid Bluetooth device for the algorithm to return is anything within some meter distance of that tester location. So basically draw a circle, anything in that circle, any device in that circle is valid. And so using that metric, once we set the radius to 17 meters, we had 100% accuracy, where every device returned was within the 17 meters of the location. When we dropped it to 10 devices per floor, that shifted from 17 to, I think, 19 meters.
Yeah.
So at least going from 20 to 10, there was there wasn't a too significant a drop in success rates. So presumably, if we continue dropping it, we'll probably be okay too. But I mean, obviously, if we get down to one Bluetooth device, we're probably not going to get anything good out of that.
But that we're planning to study the density, the relationship between the density, always looking for that, some way to optimize the distribution, because, they cost money. They're not that expensive, but they cost money.
Do you know, have you looked at how many devices you have to get in order to get 100% accuracy?
That's what we're working on. So we're going to keep, we had 20 per floor, then we went to 10 per floor, and as he just described.
I mean, in the algorithm, in order to compute like how far away they are, or have you got the trilateration, or have you looked at that at all?
Trilateralization, we haven't actually done any real work on yet. It's
Research.
It's just currently, we haven't done anything for. We just finished setting it up for just getting the closest Bluetooth device, and then setting up all the grading for that.
The reason I ask you is because there was a debate on how many the PSAPs want to get the raw data, and they want to do their own calculations. And the telephone companies are just going to send them, this is the location, just one location, which is pretty much, I think, what you're doing.
Right.
But in order for the PSAPs, the argument was, well, how many are we going to send you? Are we going to send you 100? Are we going to send you 10? There must be something you can do to figure out how many of these you need in order to compute an accurate location So we know there never be more than 5 or there never be more than 10, so we can, understand better what kind of data we'd need to compute the location.
Ideally, when we started this out and when this was like in pre-design phases, ideally my idea was one Bluetooth beacon per room and maybe 2 per floor, because these beacons were great in line of sight. So if I put 2 per floor, 2 per hallway, and just 1 per room, the concrete walls, like the bleed through even walls is very little, to the point where if you put a beacon here in this room and walk over to the next room, the signal just reduces by like 80%, right? Yeah, so about 80% or something like that. So in an ideal scenario, 1 per room is what I would envision it to be, and then maybe maybe like a 2 per hallway to just identify which side of the hallway you are in.
But I don't think that's what he was asking. I think that because it's a good, discussion point, but I think, and correct me if I'm wrong, that you were saying it sounded more like you're saying, how many data points do you need to send to your location server before it can accurately make a calculation of your location? Okay, so what we did is we just collect the set of all of the beacons that we see, and we send that set to the location server and let them figure it out. And so what you're saying is the PSAP doesn't trust anybody else to do it. They want to do that themselves. But the reason that the NIAD was first designed or proposed was to have that operation done somewhere on the network and the information sent. And I think part of the reason the PSAPs don't want that is they don't trust the carriers to do it in a timely fashion. They'd rather do it themselves, and the first responders are feeling the same way. Just get me the data because we can't wait for you guys to do it. But if they wanted to use our location server and database, the PSAPs could do that. We just send them this set. There might be 5 guys that we see. There might be 7 guys that we see. There might be only 3 guys that we see. We're going to use whatever data exists, right? We just input that into the data,
Right.
into the location server. It dips the database. It pulls this information out, and it does its calculation.
Right. What I was suggesting is that, there's a lot of dimension return. And so after X number, you don't need it anymore. You've already got it down to the nearest third.
Correct.
What is that number? That's something,
But the point is, do you want the phone to think about all that? You could send that to the database. The database could. Okay. Go ahead.
What he's asking is how long do we have to wait at a single location to determine this is my location, right? Like, what's the minimum? The minimum amount of packets we have to get. No. No. One would be enough if trilateralization will work with 1 packet if our SSI was actually constant. But standing at the same location, you jump around in value. It's not a very reliable metric. It is to a certain degree, but it's not stable.
But they take actually from one device, what he's saying, in a 10-second period from one device, right? We'll get 20 reports because the Bluetooth is popping every half a second. So the 20 aren't all the same number. There's disturbance in the field.
Is there a risk that smartphones are going to incorporate inertial measurement via silicon? before the use of Bluetooth beacons is going to be prevalent. So if you have essentially this sort of combination of GPS outdoors and then essentially inertial measurement unit as it walks around the building, does that not allow the phone to place itself more accurately without the use of sort of external broadcasters? No, like essentially inertial guidance units miniaturized into silicon on a phone.
I don't think we quite understand the question.
As I was saying, for future for indoor positioning in future, there's a number of ways you can work out where inside the building you are. One way is to use recognition of a beacon or Wi-Fi or perhaps a cellular small cell. Another is for the phone itself to track its own position as it moves through a building. By knowing that it's a certain number of steps from the front door, that it's gone up a certain amount. You actually have sort of silicon gyroscopes essentially, which can position the phone through an internal mechanism. I don't know if you've done a comparison of all the different ways of doing indoor navigation.
We did do the comparison back in the day before we even decided to go with the Wi-Fi project. That's how we decided to do it. But then we found out that GPS tracking and GPS signal tracking is actually a lot less accurate than you might think it is. I mean, it's great if you're driving, but it's not great if you're inside a building, because for GPS to work, you need a clear line of sight to the sky. And yeah, and if you're inside a building.
You're saying that GPS will tell you exactly when you enter a building,
Mm-hmm.
and you can use the sensors on the phone to figure out how much you're walking, accelerometers, gyroscopes. You see what I mean?
Yeah, no, I understand, and that's the other side of the problem, because if you start using that, gyroscopes and accelerometers also consume a lot of battery. They consume a lot of battery. So sure, it'll work, but we'll probably be carrying Motorola bricks like how we did back in 1985.
And you have to remember, we are designing to the FCC mandate, which said Wi-Fi or Bluetooth. So, I mean, and it was, when we talk about the platform, and to get back to Jerry's question, which I think we kind of short-circuited there, we were working to that requirement, either Bluetooth, or it was actually Bluetooth and/or Wi-Fi. And, in all of these, you're going to need to map the building. You're going to need to know what the building looks like. One of the reasons we tried to abstract the platform from the specific application was we were thinking, what if, there's probably a lot of people who would like to write applications that need your indoor location. So one of the things that we thought of, and that Dee had alluded to, was what if you wanted to make your building, have an automated seeing eye dog? So if I'm a visually impaired person, and I have this app on my phone, or my phone is set up for this, I walk into a building and I do a voice activated, I'm trying to get to office number 1303. So then using the indoor location platform, the PiLot platform, my application could then say, okay, I see where you are, walk 13 feet, take a right, the elevator is, and so forth and so on, so that we would use this platform for something other than NG location. For that, we said we need more accuracy than I'm in the northeast corner of the third floor, that we would need. So that's why the trilateralization concept, and I want your XY much more accurate. I want it within feet now, so I can tell you take 3 paces and stuff like that. But, the earlier question about mapping the RF, that's going to help. But you didn't actually explain the 3 algorithms that you're currently using, and you didn't actually explain about when the phone notices it's a 911 call, for example. It actually takes this 10-second sample. So if you want to talk about that, Alberto, at all. Okay. Anyway, there's a big variation in the power that they receive, even in those 20 samples. So they take an average of them and send that average.
Well, no. We take all 10 of them, and then we send that whole thing.
But then you
And then
take
the
it.
server takes the average.
It takes
if
the
it wants
average,
to.
yeah. Yeah, the phone is, one of our requirements was the phone shouldn't have to do too much work, because we don't want to eat up the battery. So we left most of all the heavy lifting really to the server.
How much difference will it make in terms of RSSI? In terms of mapping the RSSI distance? Bluetooth beacon, so you're talking feet. Oh, sorry. So the question is, you're mapping signal strength to distance, right? But we're talking only 10 feet or 20 feet, maybe, I don't know, 30 feet. So in terms of accuracy, you're pretty much going to know where you are if you're getting a beacon from a certain Bluetooth access point. So how accurate do you have to be in the RSSI? And the second question is, why are you triangulating? If I'm hearing that you're taking it from 3 places and trying to map the point, how much more accurate will that make the location?
Triangulation is good for cellular situations, right? Right. Well, the idea is just that we would like to be more accurate than, or rather, instead of telling you your Bluetooth, the closest Bluetooth device, we get your location, which we presumably can do. There are more things you can do with when you have your location rather than what you're kind of close to. For the purposes of 911, it makes perfect sense. It just all you really need is a room number. You don't even need that much. You can probably give them a quarter of the room that they're in, and that's probably good enough because a firefighter, he's a human. He's capable of looking around a bit or listening, and. Not exactly, because 30 feet, you could be in a different floor. No, so floor is important. We need to get rid of the floor and get you on the correct floor. But if you're on the correct floor, we don't actually have to be that accurate, as far as I can imagine. There's because.
That depends on where you've placed the Bluetooth. So we strategically place the Bluetooth in each of the restrooms on each of the floors, so that when in the location database it shows up as ladies' restroom northwest corner. So we took care of that, and that's like ASCII text, and that that will show up, and that's all done in the XML. That's the application specific, but. So that does show up, and that has to do with the art of originally where you're placing these. So, for example, if you did a thing where you did both Wi-Fi and Bluetooth, then you might not have Wi-Fi in the bathroom. So you might just put the Bluetooth in the, something like that. So you have to think intelligently about the building if you're going to do this.
Yeah, that is I think one plus point with respect to BLE, where you can. Based on one single BLE that you have homed in on, you can actually say what that location is. I mean, if it is a small enough room, for that matter. If it is going to be hallways or the directionality that you are looking for, like northwest corner, to guide the first responder before you actually say, where that particular room is, then triangulation also helps, like you mentioned, the number of feet or the direction of the, like northwest corner or some other thing.
Yeah.
So I think that combination helps, right?
Yeah.
Like you mentioned, yeah. So therefore, triangulation is useful.
If you're very close to the sensor and you can't triangulate, if you only get access from one sensor because you're very close to it and you're too far away from the next sensor, how do you plan to triangulate, or what's the process behind that?
Presumably, in that case, you wouldn't triangulate. All you'd say is he's within range of this device, because if it's placed in such a way where there's only one device that can ever see you, then I don't think there's much more we can do. At best.
I think that will be the detail of the triangulation algorithm they are working on.
It's actually called trilateralization, I think, because you're going to actually have more data than you have equations. And so there's a fairly complex, there are various papers that describe to you how to do this, where you actually have more variables than you have equations to solve. And so there are optimizations and methods for figuring that out. But yeah, But I think one of the things, we're probably running out of time, but I think the question of the floor is something that the students addressed very early on. And they've been quite accurate with floor, if you wanted to explain the voting process.
So at least as it turns out, if we just, I don't remember what the rates were for Wi-Fi, but if we do it for Bluetooth, if we simply take the number of devices that actually spotted you and like group them by floor, and then we just take the floor which had the highest number of devices, it turns out to give you 100% accuracy, at least in the Stewart building. I would like to try it in IIT Tower where you have tons of floors, but we haven't gotten that far.
Yeah, but basically
Okay, so-
it's a simple voting process. You know, if 9 out of 10 of the guys who see you are on the 8th floor and only one of them is on the 9th floor, we go with the 8th floor.
Yeah.
It has worked all the time. We tried initially to be more complicated and take the average power per floor, but we just found a simple vote worked. Yeah.
Yeah, just want to be mindful of the time, as Dr. Davids pointed out. There's a keynote coming up at 11 o'clock.
Yeah.
So we will have just probably 1 or 2 more questions. Subsequent questions, I think we can take it offline too.
He's got the last.
Bluetooth range extender, repeater, amplifier will confuse these things.
He's asking if there's a Bluetooth.
Is there
repeater.
such a thing as an extender, a range extender? I
Yeah.
guess there is, which is
That
much
would be
cheaper.
bad for us.
Yeah, but the Bluetooth range extender. The Bluetooth range extender is that right? That's probably not compatible with the Bluetooth beacons, because range extender extends the range so that you can have a two-way communication between two Bluetooth devices. Here, we just have a bunch of little kids screaming at the top of their lungs saying, "Hey, I am here, notice me." And then the phone notices them and says, "Okay, I'm here because I see all these screaming children."
Also, if you extend the range, it's going to give you a false idea of how about where it is. When we have to know, we put it here, and it's got to die by the time it gets here. Actually, we see them all the way from one end of the corridor to the other. They're very cool, like minus 92 dBm, but we can see them pretty far away. But you don't want to extend their range, right?
I'm not sure it's point to point.
It certainly isn't applicable.
No.
These are iBeacons that are just standing there, like he says, yelling.
This thing can confuse the situation of the building. Can it?
I'm sorry, I didn't understand.
Can it confuse everything if it's all of a sudden installed?
If somebody started putting Bluetooth extenders in the building, would we get screwed over?
No.
I don't know.
No, you can't, because the Bluetooth extenders need to be configured to work with these things, and for that they need to have some form of communication with the devices itself, and the devices are set so that they will not receive any incoming communication. All they're doing is just outgoing communication, and a Bluetooth extender can't really extend a signal if it doesn't know what the signal is.
Like you couldn't, okay.
Have it turned on, you need to connect to the extender for extending.
The point is this.
I don't know.
Could you do an extender for your radio? I'm a radio station. Think of the Bluetooth beacons like a radio station. They're just broadcasting. They're broadcasting unless you own some equipment that can pick that signal up and rebroadcast it. And we're not doing that. There's no way to talk to these guys. They're really dumb. We're going to have to stop now because people got to take a break and they got to come back and hear Dean right next door in 20 minutes, I think. Right? What?
Thank you.
We are having fun. It's great. We could take this whole thing out there and have a cup of coffee and talk about it. But we got to show up in that room. We got to show up in that room in 20
Yes.
minutes. Yes.
Thank you very much. And on behalf of the IoT track, I'd like to thank the steering committee and all the volunteers, as well as the video streaming staff and others who have made it possible through this room as well as the rooms yesterday. Thanks. Bye.
What are you saying about was that if you take an extender, which it traps it to both the signals and then it just repeats.
That would be deadly for our.
Right, but anybody can do that.
Oh.
All they have to, because you can also just imagine a situation